Okay, guys. This is my first time using this. I think they call it Screencastify. So bear with me while I'm getting this done. Hopefully, it's not too weird for you. It is kind of weird for me. This Screencastify only allows 10 minutes for a free account. So I have 10 minutes to get to a lot of information. Then I'll pull up another video that the sub can show you while I'm away at Lynchburg College and so forth. So you guys can get prepared for the benchmark that's coming up. I'm going to show you right here. This is your par guide, and I'm going to zoom down a little bit so you can see better. There you go. You can be tested on anything right here on the quarter two or the second quarter. And what I'm trying to do is get through a lot of information in just 10 minutes, and it notifies me like 30 seconds before the video is going to close. So I'll have to do a quick wrap up, and then I'll do another video where I left off at. Okay, again, I'm just going to hit the big topics and try to go through as many of these as possible, and the sub can just keep showing them until the end of the class. All right, the atmosphere. I'm not going to show you anything with PowerPoints. I'm just going to go over what the SOL says here and touch on the big topics, just to remind you. All right. Basically, if you look right here, scientific evidence for atmospheric composition changes over geological time. The chemical makeup, how it's changed over geological time, and how humans and other animals can impact that, and the mechanisms of density differences and energy transfer. Okay, the composition of the Earth has changed over geological time. All right, the first atmosphere was primarily hydrogen, and that's what it's saying right here. It says hydrogen and helium, but really, think about hydrogen. That's the most simple element in the universe. 99% of the universe is made of that. The first atmosphere of Earth about 4.5 billion years ago was just a nasty, nasty place. It was hydrogen. No life was here, and extremely hot. There was some water vapor in the air, but nothing to where it could condense. It was too hot for the water to condense and form as rain. So hydrogen, and then you had Theo coming and hitting the Earth at an angle, and that create the second atmosphere. Think of these huge explosions, these huge, a little bit later on, volcanic eruptions, releasing a lot of CO2 that was trapped inside the core of the Earth, releasing that now. And once the Earth has started to cool off, so I don't know if you guys can hear that. I think it's an Iceman truck or ice truck or ice cream truck going by. It's kind of weird. All right, anyway. Once it's cooled off and all the CO and CO2 has been released, then you have water vapor condensing as rain droplets. Yay, so now we got some water going on. It's cooler now. We have CO, CO2 in the air. This is the second atmosphere. Of course, you still have the hydrogen and helium. And then something amazing happens that no one knows how. You have life appearing in the ocean. And when life appeared in the ocean, what it did, it was an early photosynthetic bacteria. And photosynthesis, it sucks in the carbon dioxide and puts off oxygen. So you have the CO2 levels going down, which decreases the heat even more. And then the oxygen coming out, which allows later evolution for life to come on the land. So that was the third atmosphere. So first atmosphere, hydrogen, helium. Second atmosphere, CO, CO2. You do have some other things going on there like water vapor. And then the third atmosphere, you have CO2 levels going down and O2 levels going up. And then later on, you have nitrogen and so forth being added through life. And that's what that is saying basically all through here. I just really went through it very quick. Again, it says after the moon was formed, is really Theia hitting, and then the moon was later created. Photosynthetic life, and yeah, then it says photosynthetic life generated oxygen that animal life became possible. Animal life coming onto the land. Now everybody thinks oxygen, 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 which oxygen is very important because it's for us. But that's not the big guy in our atmosphere. The big guy in our atmosphere today is nitrogen. 78% of the atmosphere, the air you're breathing right now, is nitrogen, and 21% is oxygen. That leaves 1%. The other 1% is like water vapor, CO2, and some other trace gases that my memory right now. Human activities, yeah, we can change things. Just like that piece of coal I showed here recently, that is full of CO2, and if we burn that to generate electricity, that's gonna what the CO2 that was trapped is going to now be released into the atmosphere, and that's a greenhouse gas, and that can trap heat more. And that's why they say global warming. We want to prevent that. Also, geological activity. That's what we're talking about, like volcanoes and so forth. And volcanoes can shoot, of course, tons of gas into the air. It can be carbon dioxide, sulfur dioxide, it can be water vapor, and some others that are released into the air from volcanic activity. And that's kind of what that's saying there. Volcanic and meteorite impacts can inject large quantities of dust and gases into the atmosphere. Excuse me. Now, what they're saying right here, meteorites, kind of cool because that's where 50% of our water came from on Earth, the very first atmosphere during that time. And the second atmosphere, you have meteorites coming just smashing into the Earth. The solar system hadn't cleaned up all the debris yet. It's a very nasty place. So you have these meteoroids becoming meteorites when it hits the ground, and they release a lot of moisture onto the planet, and that helps to increase the amount of water on the planet Earth. About 50%, they say, of water that's on Earth right now come from meteorites crashing into the Earth early on. All right, the ability of the Earth's atmosphere to absorb and retain heat is affected by the presence of gases like water vapor and carbon dioxide. Water is a great heat absorber. Actually, I think I told you a little bit down the road throughout this year, after this lesson, after this topic that we covered in class, that the ocean is the heat engine of the Earth because water holds heat. And I took that balloon and put a little bit of water in there, and I put it right above a fire, and you guys saw how the water in the balloon was absorbing the heat from the flame. Water vapor can do the same. Water vapor can absorb a lot of heat. So yeah, carbon dioxide, water vapor can absorb a lot of heat. We want to keep our water locked up in glaciers. We don't want that to melt because then you have more water vapor in the air, and that's just even going to expound upon the global warming phenomenon. So we want to keep glaciers where they are. We don't want them going away. All right. Let me see what else they're talking about here. No, I covered that pretty good. I need to go into the troposphere and thermosphere and mesosphere and all that. I'm going to do that in the next video. All right, be back in a second. See you guys.